Welcome back to the second tutorial in this series of tutorials for Engineering 205. Today I'm going to demonstrate the nodal voltage method. Again, try to do the problem by yourself before you continue watching the video. Let's begin. Consider the following circuit. We would like to use the nodal technique to find the value of the current I0. The first step in the nodal voltage method is to identify the essential nodes and then to pick one of them as the reference node, which is the node with 0 volts. Here are the essential nodes in the circuit. I will choose the bottom node as the reference. So here are the node voltages labeled. Now notice that V3 is the voltage from node 3 to ground. Notice also that the 60 volt voltage source is connected to node 3 and to the ground. Therefore, V3 has the value of the voltage source. So V3 is equal to 60 volts. This means there is no need to write an equation for node 1. The next step is to write KCL equations at nodes 1 and 2 in the following manner. Notice that node 1 is connected to 3 branches. Therefore, the nodal equation must have 3 terms. We will assume that the currents are leaving node 1 as follows. And then we will express these currents as a voltage drop divided by the value of the resistor. Let's see the nodal equation for node 1. The first term corresponds to the current in this direction. So it's V1 minus V3 divided by 4. And the second term corresponds to the current in this direction. So it's V1 minus V2 divided by 2. And finally, the third term corresponds to the current in this direction, so it's V1 minus the ground, which is 0 volts, divided by 8, and this equals to 0. Now for node 2, we will again assume the currents are leaving node 2. However, for this branch, since there's a current source, we will use the value of the current source. The nodal equation for node 2 becomes V2 minus V3 divided by 10 plus V2 minus V1 divided by 2 and then minus 3 I0, which is the current source. Now we have 2 equations and 3 unknowns. Therefore, we need an extra equation. This extra equation involves the current I0 and is given by I0 is equal to V3 minus V1 divided by 4. All what we need to do is to simplify these equations. So substitute V3 equals 60 volts into the 2 nodal equations, and then let's substitute for I0 into equation 2, and then we can simplify the 2 nodal equations by multiplying equation 1 by 8 and equation 2 by 10. And this gives the following 2 simple equations, which after solving for V1 and V2 gives V1 equals 53.07 volts and V2 equals 62.88 volts. And finally, I0 is equal to V3 minus V1 over 4, and after substituting for V3 and V1, we have I0 is equal to 1.73 amps. And that's the end of this example. Great. I'll see you in the next tutorial.